Hello friends, my name is Tejendra Jangid. Here I am discussing the solution of Assistant Executive Engineer Telangana for previous paper. Okay, and next video is coming soon for the solution of Assistant Executive Engineer Telangana previous year paper. And coming soon solutions are previous year engineering paper, Power Electronics P.S.Bimbhra, EMFT Matthew and OSIDQ, Electromagnetics SOMS Outline Series, Signal System SOMS Outline Series, and many more. So don't forget to subscribe that channel. That is, anybody can download education at ABCD Education. Okay, so do not forget to subscribe this education channel. Okay, now come to the question number 46. A 250 volt DC shunt motor takes a total current of 20 ampere. The resistance of shunt field winding is 200 ohm and that of armature is zero point 0.3 ohm. Then the armature current is. Now come to the solution. We know that this is the DC shunt field motor, DC shunt motor, where zero point 0.3 is the armature and this is the field resistance, and we applied 250 volt. Now this 250 volt flow the 1.25 ampere field current. Okay, now due to this the armature current is 18.75. Okay, so the armature current equals to load current, this load current minus field current. Okay, so it is 18.75, so the answer is third. Now come to the question number 47. The voltage regulation of an alternator depends on. These are the option. Now come to the solution. At lagging power factor, the voltage regulation can be find by the help of phasor diagram. Okay, so here in the phasor diagram we find the value of E. Okay, induced voltage. This induced voltage is find by the help of these component V cos theta, IARA, V sin theta, IAXA. So the by the help of Pythagoras, E square equals to this square plus this square. Okay, so in this equation, E minus V upon V is the voltage regulation. So E is depend on IA, cos phi, RA, IA, XA, and theta. So the both load current and power factor is depends the voltage regulation. So the voltage regulation depends on the both load current and power factor. So the answer is third. Now come to the question number 48. The distribution of load between the two alternator operating in parallel can be changed by changing the. Now come to the solution. We know that load frequency control. In load frequency control, the alternator power is can be controlled by the help of this uh, slope, slope, load frequency slope. Okay, so there is the load and there is the power input. Okay, so that here we can change the load by the help of when these are connecting in alternate in parallel. Okay, so we can change by the help of input, prime over input. This is the prime over input. Okay, so uh, driving torque of prime mover is used to change the load. Okay, now come to the question number 49. In case of power transformer, the load current in terms of full load primary current is. In the power transformer we use iron core, and but in the case of three phase induction motor, the air gap is introduced. Due to the air gap, there is a 30 to 40% of no load current, but there is a no air gap. Here we use iron. So here the load no load current is very low. In so the it is 3 to 4 5%. Okay, 3 to 5 3 to 5% of full load primary current. Okay, so the answer is first. Now come to the question number 50. The starting torque of induction motor is maximum when these are the option: Now come to the solution. We know that this is the condition for the maximum torque. Okay, so this is the maximum slip, and this is the R2 upon X2. Okay, so at the starting, slip is equal to 1. Okay, due to the nr equals to 0. Okay, so ns minus nr upon ns, that is a slip at starting is equal to 0. So at the starting, rotor resistance equal to rotor reactance. So the answer is first. Now come to the question number 51. In an alternator for zero leading power factor, for the zero leading power factor, the effect of armature reaction is. These are the options. Now come to the solution. We know that this is the field MMF. Now, in this is the induced EMF, which is led by 90 due to the E equals to minus n d5 by dt. Okay, so at leading power factor, so the current Ia is 90-degree lead. So due to this FAIA in the direction of Ia. Okay, so it is in the direction of field mmf. Both are in same direction, so it is magnetizing in nature. So the answer is first. Now come to the question number 52. The V curve of synchronous motor show the relation between the following quantities. These are the options. Now come to the solution. We know that these are the V curve which are show the relation in between the armature current and field current. So the answer is first. Now come to the question number 53. Which of the following motor is suitable for the high starting torque? We know that in the series motor, the series field is in the series of uh, armature current, load current. Okay, so so the torque is directly proportional to square of armature current. Okay, so so it produced very high starting torque for the high load. So series motor is used for the high starting torque. So the answer is third. Now come to the question number 54. In the DC generator, we with the lap connected winding, the number of brushes required is equal to. Now come to the solution. For the two-pole machine, we use two brushes. For the four-pole machine, we use four brushes. For the six-pole machine, we use six brushes. Okay, to collect the armature current from the armature. So these are directly proportional to pole. So the number of so the brushes required is equal to number of poles. So the answer is first. The field winding of the alternator is excited by. Now come to the solution. Now this is the three-phase alternator where field is rotor is applied by the help of rotor is supplied by the help of DC field. Okay, this DC, this not a DC field, DC supply. Okay, correct, is DC supply. So due to this DC supply, this N and S pole is not changed, they are fixed. Okay, so it is constant. Okay, so if we use AC supply, then N S pole are continuously changed. So the direction of the N S pole is continuously changed. To make the constant direction, we use DC supply. Okay, so the N and S direction is same for the uh, whole time in the DC in the synchronous generator. So we use DC supply to make constant field, constant direction field, not a constant field, constant direction field. Okay, same direction field. Now come to the question number 56. A three-phase transformer rated for the 33 kilovolt and 66 kilovolt is connected in star delta and protecting current transformer on the low voltage side has the ratio of 405. Then the suitable CT ratio on HV side in this side. So we know that this is the transformer star and delta, and the phase voltage of this side, star side, that is 11 root 3 kV. Okay, so phase voltage uh, is equal to this is the turn. Why it is inversely? Because this is the current ratio, not a voltage ratio. Okay, so Now we 1 by n equals to 5 by 400. Then we get n equals to 80 equals to 5 root z. So the answer is third. Now come to the question number 57. For the complete production of the